Hi everyone, welcome back to Abra Knowledge channel. Today we are going to discuss DoE, design of experiment, and this is my follow-up video. The last video we talked about very basic thing, what is called main interaction and then what is called interaction plot. So only these two elements we dwell, and in this particular one we are going to do it all together. Including the interaction plot and factorial plots and how to perform the DoE, what is meant by center point, what is meant by blocks and all that we're going to study. And this is coming from and also we're going to do it in Minitab also as well. And the book name is Total Quality Management, 5th edition, Pearson edition, and page number 521. Let's go to the data set. So this is the data set I have. So it has been taken like 8 runs. DOE runs are 8, and this is the treatment condition. And they have 3 factor. One is called speed is a factor. Another one is factor is pressure. Another factor is time. So all these been converted into 1 and 2. For example, 1 equal to 25 minutes per seconds, and then 2 meaning like 35 minutes per seconds, and then you also have the pressure. Then the pressure again you have that one denote 50 and 2 denote 75, and then you have a time, 1 denote 5 minutes and 2 denote 10 minutes, and then you also have a response rate. So what we are going to do is we are going to study main, effect, interaction plot, factorial plot, cube plot, DOE, and response. These are all the things we are going to study now. Very interesting. And as I said that the factors are 3 and the response is 1, right? So it is also given in the text also as well, but I'm going to do directly in Minitab. So all these values been already pasted there. Whenever we do the design of experiment, the very first thing what we need to do is we need to go to stat, DOE, and factorial, right? In the factorial, we need to define it, right? Define custom factorial design, right? Have a go and click it. The factors are C2, that is speed, C3, that is pressure, C4, that is time. Have a go and select it, and then we need to tell that system like we have given like 1 and 2 alone, right? So 1 and this is coded. When you have like 1 and 2 or -1 +1 or 0 1 and all that, that is called coded. Uncoded meaning like is a text, right? When you have a text also you can give. For example, if you have some text you can also give, but here I'm gonna keep it like numeric, 0 and 1 and 2, right? 1 denote low and 2 denote high, right? I'm gonna give okay. And this design, so we don't have the structure yet, right? So we don't know the standard order, the run order, center point, and blocks. I'm just gonna give this one. So now what the system has done is system has created these 4 additional column called standard order, run order, blocks, and center points, right? So center points, we're not gonna replicate anything. That's the reason it is all 1. Otherwise, if we wanted to replicate, we can do all the replications, randomizations, and all that. There are a lot of other topics within the design of experiment, and also up to Taguchi model, which we are gonna see in the upcoming videos, right? So now the plan I have done the define, right? Once a define is done, right, this is what we have done in the factorial. We have done with the define, and then what we need to, once a define is done, automatically this is coming up, analyze one. Once you do analyze, all the other tabs will come up. So now I'm going to do step number 2, analyze. So analyze the responses, the output, right? We're gonna interested in responses, and terms you can give. We're going to keep it like all the terms, like speed, that is A, pressure is B, and time is C, AB, AC, BC, ABC. These are all the 3 combinations. I'm not going to remove anything. I'm going to keep all of them. And then I don't have any covariant, and stepwise we can do it later. And you can see graph. So all in one, you will get the Pareto also as well. Okay, so now what you can see here in this one, first I will go to the summary. In this summary, alliances is also A, B, C, A, B, A, C, and B, C. And the factors, as we said, that A, B, C, that is speed, pressure, and time. And then what else? We have a very important value. So this is the equation it has given. That regression equation. This is uncoded equation. You will also find it for coded also as well. Since we have given a coded, you will also find for coded also as well, right? So this is the values we have got. Now what we are going to do is, so coming back to this one, nothing is significant because the error is 0, right? So we have not replicated any samples, we have not done any extra points and all that. So p value shows that it is all, no value is being given. If you have an error, you will definitely will get the p value in f value. So let's see that graph, this Pareto. This Pareto shows that nothing is insignificant, nothing, everything is important. Nothing is, no, there is no significant one. We have all the three terms is coming up like AC and all that. So what we need to do in such cases, give Control E, you can go to stepwise. You can perform like three things. We can perform like stepwise, forward selection, backward selection. Maybe I will start with the stepwise, and then alpha value it says 15%. Give OK, and now I will come back to this residual plot later, and you can see now if I do that, only the factor which is critical factor is, that is significant factor is only B, right? So B, you know, B is all about the pressure, right? So B is the one which is significant factor, right? Similarly, you can also do like backward, and whatever the model works for you, you can do it. For example, forward selections, I'm giving OK. I will come back to residual plot and also says that B is the one. And similarly, I will go and do it the other one also as well. Backward eliminator. I will give OK, and I will give OK. I'll come back to residual plot later, and then it says significantly B is a 1. And you can see that you can take any one equation which is which has that best R square value and all that, because interaction also important. As you can see, this is a normal distribution and horizontally deploy. I mean, this is horizontally spread, and this is perfect histogram, and then there is order, there is a zigzag shape is there, so no concerns on the residual plot. So this is a B factor is the important one. Now the third thing, now what we can do is, I'm going to DoE, within DoE factorial one, and what we have done is this analyze one, and then you wanted to have both the things together. Like factorial plot is a basically combination of main effect and interaction plot that you generally do it in using that ANOVA, right? Main effect and interaction plot, right? That things can be done directly from this. Once it is done, the other things has been opened up. Factorial plots, I'm just giving it. And then these are all the three responses. Response is this one. This is the three things I have. And only available model, I'm going to take it all this. So this is for pressure. Similarly, what I can do is I can just do it for all terms. So now I will select all the three terms. I have added here, I have added here, I have added all these terms, and okay, only for this model I'm just giving back, okay, and all terms, and then give okay. So you, as you can see here, that there is interaction is coming up for all these three, right? So how the pressure is being interacted, if the time is low, the pressure, the response rate, the time is low, the response, the speed, if you see here is speed, it's not much correlated in interacted, but pressure is a one significant one, right? So this is the summary you can get it from this. Not only that, you can also perform, I'm just going back and give okay, I mean factor DOE factorial, and then other thing cube also. This is very interesting. And now you can go fitted one and the pressure and give okay. I will take the response and give okay. What it says here is, this is a beautiful one. You can see here, if the speed is being kept low, we get the less pressure, and if the speed is kept high, we get the more time. And all these three, like speed, pressure, and time, all these three you have. And with respect to response time also we have, right? This is on the means. Similarly, on the fitted lines also you can do, and you can do one by one also as well. You can do the pressure. Let's say you wanted to see how's the things for the time and all that, you can keep adding those factors. And this is plot also we have done. the last but not the least, we can also do this is interesting part, response optimizer. Identify the combination of predictor values that jointly optimize one or two fitted responses, and then let's say the response time I wanted to improve, right? For example, standard deviation, like we always say low, and deep defect we should always have low, right? Yield we should have more. Like this response rate, in this case, I'm gonna give it like high, maximize. And then it also gives that setup. In the setup, if you wanted to have like, if you have any other target you wanted to give, we can give. So importance, I'm gonna give it 1, give okay, give okay. So it has given like the, if you wanted to get the response is you will get like 3.9, and the setup you need to do is you need to keep the pressure as 2.5. That's the recommendation Minitab has given, right? If you keep it like 2.5, you will get it. Let's say I'm keeping like 3, what will happen? So that means this is again, I'm keeping like 2. So what will happen? So the your response will get impacted, right? And you can also do that changes also as well, right? It automatically gives it, and all these point it automatically gives it. I hope you enjoyed this video, and we have done just a quick recap. First thing what we did, first DOE we did factorial. In the factorial, DOE factorial, first thing we did is define, and then we did the analyze, then we did factorial, then we did cube, then we did response. And what is the first important step must to do is the define. Only when you define it, it gives a center point, blocks, and all this one. So once it is done, you can do analyze, and then and this is optional actually. Even if you wanted to have a cubic one, you can do that also as well. I hope you enjoyed this video. Please do like, share, subscribe my channel. You have a wonderful day ahead.